Probability in everyday life. The study of genetics applies theoretical probability calculations to predict the chance of various traits in offsprings. For example, if we had a parent with brown eyes and a parent with green eyes, their child would have 50% chance of having brown eyes, 12.5% chance of having blue eyes, and 37.5% chance of having green eyes. The probability of an event occurring is shown with a number between 0 and 1. This number states precisely how likely it is for an event to occur, with 0 being impossible and 1 being certain. It is often written as a fraction or a decimal and can indicate how frequently the event would occur over a large number of trials. Because we are using fractions and decimals, that is why it's between 0 and 1. When using fractions and decimals, a whole or a certain chance is 1. So we use these fractions and decimals to represent the probability. For example, if I toss a coin, I could expect that heads would come up about half the time. So therefore, my probability is represented by the fraction 1/2. Or if I was to roll a dice, the probability that the number 4 would come up would be 1 in 6. So the fraction would be 1/6. When we're calculating probability, we want to be pretty precise. So in this example of rolling a dice, we would want to write out all the possible outcomes of rolling the dice, which would be 1, 2, 3, 4, 5, and 6. Doing this will really highlight that there is 1 chance out of 6 to roll the number 4. And it can also show that there is 0 out of 6 chance that we could roll a 9. We have some words we need to know. Experiment. A random experiment is a chance activity that produces varying results. A trial is a single component of that experiment. For example, flipping a coin, rolling a dice, spinning a spinner. An outcome is a possible result of the experiment, like rolling a 5 or tossing a coin and getting heads. The outcome is all the possible options. And an event is either a single outcome or a collection of outcomes. Our event could be rolling a 3, or rolling an even number, 2, 4, 6, or rolling a 3, 4, or 5. The probability of an event occurring is between 0 and 1 inclusive. As I said, we represent this as a fraction, and we can see this fraction here. Now, what we know about fractions is what we want is on the top. Now we can see here on the top is the number of outcomes where the event occurs. And we'll talk about this more. And then the denominator is always the total. And here it's the total number of different outcomes that could be possible. Probability is often written as fractions, but we know we can convert fractions to decimals and percentages. So they can sometimes be represented in those different ways. We have another word here, sample space. And this is a list of all the different possible outcomes that could come from an experiment. Whenever we are calculating the probability, we always write PR to represent probability, and then we put the event or situation that we are analyzing in brackets. For example, we have here PR green, which would represent the probability that the outcome was green. Let's have a go at calculating probabilities. Let's do some together. It says a fair 6-sided dice is rolled. A is list the sample space. Now we know that the sample space is a list of all possible outcomes. When we write the sample space, we actually first write the word sample space. Then we do an equal sign and we do some brackets. Now we've got to list all the possibilities of rolling a dice. We could get a 1, 2, 3, 4, 5, or 6. And that is the whole sample space. B says, find the probability of rolling a 3, giving your answer as a fraction. So I've got to find the probability. Now I know now my new formula. So I have to write PR to show that I'm finding the probability. Then I've got to write the event I want to analyze in brackets. And I'm doing rolling a 3. So I'm going to write 3 in brackets. Now we write equals because we're figuring out what the probability is equal to. Now we know that the numerator is how many times this event will occur. This is when we look to the sample space. How many times can the event 3 occur? Well, there's only one 3, so it can only occur 1 time. Our denominator is then the total number of outcomes, how many different options we have. And again, we're going to look at our sample space and we see that there are 6 different options. So it's 6. So the probability of rolling a 3 is 1/6. And it's said to write our answer as a fraction, which we have done. C says find the probability of rolling an even number, giving your answer as a decimal. So again, I'm figuring out the probability, so I'm going to write PR. In brackets, I need to write the event that I'm figuring out, which this time I'm doing even. So I'm going to write the word even. And then I'm writing equals. Now on the numerator, I'm writing how many times this event could occur. Now in my sample space, I need to look for all the even numbers, which I have 2, 4, and 6. So I have 3 different numbers that could produce this result. So that's 3. Then my denominator is the total number of outcomes, which is still 6 because there's 6 different options for rolling a dice. I'm then going to simplify this by dividing by 3 to give me 1/2. So it's 1/2. However, my question told me that I should write it as a decimal. So now I need to remember how to convert a fraction to a decimal. I'm going to times my fraction by 50 to give me 50/100. Now that I've got it over 100, I can put the last digit of the numerator in the hundredths place. So I've got ones, decimal, tenths, hundredths. Put the last digit, 5, 0. So my answer is 0.5. And lastly, I'm doing D. Find the probability of rolling a number less than 3, giving your answer as a percentage. So again, I'm writing probability, so PR. In the brackets, I need to write the event. The event I'm looking at is a number less than 3. So I'm going to write less than 3 and equals. Now I'm going to look at my sample space. How many options do I have less than 3? Well, I have the number 1 and the number 2. I'm not going to include the number 3 because it says less than 3. So I have 2 options in my numerator. And now look, my total number of outcomes is still the same. I still have 6 outcomes. So it's 2/6. I'm going to divide by 2 to give me 1/3. Now I have my 1/3, but my question says that I need to show it as a percentage. So to turn a fraction into a percentage, I need to times by 100/1, which will give me 100 divided by 3. This is still a fraction and I shouldn't have a fraction in my percentage. So I could convert the denominator to 100, but I know that 3 doesn't do that very nicely. So I'm going to divide the numerator by the denominator. 100 divided by 3. 3 into 1 goes 0, 1 left over. 3 into 10 goes 3, 1 left over. 3 into 10 goes 3 with 1 left over. So I'm going to add a decimal, add a 0, put a 1. 3 into 10 goes 3, and I need to carry that decimal up. Now, I've kind of realized that there's 1 left over, which means I'm going to keep recurring forever. So I'm going to stop and put a dot above the first 3. So my answer is 33.3 recurring percent. Now you have a try at calculating probability. Let's check our answers together. A spinner has the numbers 1, 2, 3, 4, and 5, each with an equal area. It is spun once. A is list the sample space. First, I'm going to write sample space. Equals, and then brackets. And I've got to list all the options it could be, which is 1, 2, 3, 4, and 5. B, find the probability of spinning a 3, giving your answer as a fraction. So I've got to write probability, and I'm writing 3 as my event. Now I'm looking at my sample space. There's only 1 3, so my numerator is 1. Now the total number of outcomes is 5, so I'm going to put a 5. So it's 1/5 for rolling a 3. C, find the probability of spinning an odd number, giving your answer as a decimal. So I'm going probability of an odd number. Now if I look, I have the number 1, 3, and 5. That is 3 out of 5 options for rolling an odd number. I want it as a decimal, so I'm going to try to turn the denominator into 100. I'm going to times it by 20. That will give me 60/100. Now that I have it over 100, I can put the last decimal of the numerator into the hundredths place. Units, decimal, tenths, hundredths. So put the 0 here, 6 here, add a 0. The answer is 0.6. And lastly, D. Find the probability of spinning an even number, giving your answer as a percentage. So I'm going probability, and this time it's even, equals. Now the even, I've only got two options, the 2 and the 4. That's 2, and it's still a total of 5 options. I want to turn it into a percentage, so I'm timesing by 100. This gives me 200 over 5. I'm going to say how many times does 5 go into 200, or basically 200 divided by 5. 5 into 20 goes 4, 5 into 0 goes 0, giving me 40%. Mustn't forget that percent sign. I hope now you can list the sample space of an experiment and calculate the probability of a simple event, giving your answer as a fraction, decimal, or percentage.